We're going to look at a couple more examples for the fundamental accounting principle. So for our next one, we're going to analyze what can happen at the JJC Chef's Table kiosk. Now at the kiosk, there are going to be 3 different sandwich or wraps, 2 salads, 2 soup choices, 3 sides, 3 choices for baked goods, and 2 options for ice cream. Now for their $5 combo, you can choose 1 entree, either a sandwich or a salad, 1 side, 1 soup, and 1 dessert, which is a baked good or ice cream for $5. Now the question is, how many possible lunch meals are possible? Okay, so to build a combo, we have to make 4 choices. To build a combo, we have to have an entree, we have to have a side, we have to have a soup, and we have to have a dessert. So let's look at how many ways each one of these things can happen. Okay, so for the entree you can have either a sandwich or a salad. Okay, so for the entree then, if you have 3 sandwich options and 2 salad options, total for your entree choice then, you have 5 options. For your side, you've got 3 side options. For your soup, you have 2 soup options. And for your dessert you can choose either from baked goods or ice cream. So if there's 3 choices for baked goods and 2 choices for ice cream, then in that pool then you're going to have 5 things that you get to pick from. So those are going to be your dessert choices. So then to get how many possible lunch meals are there, we're going to multiply what could happen on each particular stage of building one of these combos. So if you multiply all these things together, you're going to get there's 150 possible lunches. Okay, so in this one we had to be a little bit more careful about our counting arguments in a particular category where we have some options that are available to us, right? We have to add the options that are available for us at that particular level. And then for each then possible stage then that's when we would multiply them all together. So you're going to get the wrong number here if you just pull all of the numbers out of the problem and you multiply them all together. Right, we have to be a little bit more careful on these ones, analyzing what could happen on certain stages. Okay, so our next one is going to be packing for a business trip. Now Dolores is going to pack 3 pairs of shoes, 4 skirts, 3 pairs of slacks, 6 blouses, 3 turtlenecks, and 2 jackets. Now assume that she coordinates the colors so everything can go with everything else. Now we're going to define an outfit as consisting as a pair of shoes, a choice of lower wear, either a skirt or a pair of slacks, and a choice of upperwear, and the upperwear could be a blouse or a turtleneck or both, and finally she may or may not choose to wear a jacket. Now how many different such outfits are possible from all the stuff that she's packing? Okay, so in order to build an outfit then, she's going to need to have some shoes. She's going to have lower wear. She's going to have upperwear. And she's going to have some jacket choices. Okay, so these are going to be the different stages of actually building an outfit. So now let's analyze what happens on any given stage. Now for our shoes. Okay, so for the shoes, let's go back to what we were told. So she packs 3 pairs of shoes. Okay, so our shoe options then we have 3. Okay, now for lower wear will consist of either wearing a skirt or a pair of slacks. Okay, so then going back up there we have 4 skirts and 3 pairs of slacks. Okay, so how many options then total does she have for her lower wear? 7 options. Okay, now let's go to the upperwear. Okay, so for the upperwear, she could wear a blouse or a turtleneck or pair them together. Okay, so for the blouses, she's got 6 blouses. She's got 3 turtlenecks. Or she could opt to put these together and wear both of them at the same time. Now the question is, how many options is she going to have if she wears both? Well, let's break that over here off to the side. Okay, so if she's got 6 blouse options, okay, so she could wear blouse 1, blouse 2, blouse 3, blouse 4, blouse 5, or blouse 6. Let's assume she picks blouse 1. Then she could wear one of 3 different turtlenecks. So if she wears blouse 1, she could wear turtleneck 1, turtleneck 2, or turtleneck 3. Okay, and we're going to have these turtleneck options for every single one of these blouse options because we're pairing them together. So this would be, for instance, pairing together blouse 1 and turtleneck 1, or I could wear blouse 1 and turtleneck 2, or I could wear blouse 1 and turtleneck 3. Okay, so then how many possible blouse turtleneck options would I have if I were to expand out this entire tree diagram? Well, this is going to be another application of the fundamental counting principle. So there's like a little bitty one inside this bigger problem. For this one, she's got 6 blouse options and 3 turtleneck options. So then total, she's going to have 18 options where she wears both of them together. So both, we have 18 options. So for the upperwear, she's got 6 blouse options, 3 turtleneck options, or 18 options where she has both of them. So total upperwear choices then is going to be 27. Okay, so now let's go to her jacket. So for the jacket, she's got 2 jackets, and she may or may not choose to wear one of the jackets. So for the jacket options, she could have jacket 1, jacket 2, or wear neither jacket. Okay, so this is kind of a special one here that we didn't have options for before. Okay, so she's not going to go out without wearing shoes. She's not going to go out without picking a lower wear option. She's not going to go out without picking an upper wear option. Okay, but for the jacket, she does have the option of maybe omitting it from her outfit. Okay, and we're going to consider that a different outfit if she doesn't have the jacket on. So for the jacket, there are going to be 3 options total. So then how many total outfits are possible? So we're going to multiply each possibility for each stage by itself. So if we multiply this all out, you're going to get 1,701 possible outfits.